So, greetings, students. Um, we'll be seeing about your unit 3. So, your unit 3 is all about your DC machines. So, among those, we'll be seeing about your DC motor as well as your generator. Okay, so we will be directly getting into the lecture. So in this lecture, the agenda is that you will be seeing about the construction of both DC motor and generator. The construction for these two machines remains the same. Okay, so if you're studying for the motor itself, you can also write for your generator also. Okay, so moving on, first you have to know about what is a motor. Okay, so a motor is a device, it's an electrical device, okay, that converts your electrical energy, that converts your electrical energy to your mechanical energy. So this is what your motor is up to. So as it is said, it converts your electrical energy to your mechanical energy. So this is an image of a simple motor. Okay, so the AC motor is the one which runs on your AC quantity, whereas a DC motor is the one which runs on your direct or DC quantity. Okay, so moving on to the principle of operation. So the principle of operation is mainly based upon the Faraday's laws of electromagnetic induction. As per this, whenever an current carrying conductor is exposed to a magnetic field, okay, there'll be a flow of current over it. Okay, so here you can see these are the two magnetic magnets. Here, this is your north pole, this is your south pole, and the current carrying conductor is over here. This is your current carrying conductor, or it is also called as your armature. Okay, so in the conductor, the windings will be wound. Okay, so it is also called as armature. Okay, so here they have given, they will be saying it as an armature winding, and this contributes to your stator or your static part. Okay, so this part will be a static one, whereas your armature will be of your rotor, and it will be of your rotating part. Okay, so in the construction, I'll be clearly explaining about this first with the principle. So if whenever there is a magnet, the magnetic field of force will be moving from north pole to south pole. Okay, so when it's moving, if you are introducing a conductor with a winding, and if you are making this to rotate, if you are making this to rotate, so regarding this, I have already briefed out in your first unit based upon your three phase and single phase quantity I have explained. So when this is rotating, the magnetic field of flux will be cut out. So there will be some kind of forces generated over here. Okay. So this is in case of your motor, there will be your output will be mechanical force. At the same time, in case of your generator, your output will be electrical energy. So in all the electric vehicles and all, we will be making use of only motor, not generator. Okay. So this is an image showing about your brushes, commutator. I'll be explaining about each part. Okay. So this is we'll be getting into the construction part. So this is the construction of a DC motor. Your DC motor will be having two things, which is main is your stator, and this armature contributes to your rotor. So this is your rotating part. Okay, so here you can see there will be some windings, brushes, and commutator. Okay, so here you can see clearly. So this is your stator, and here this stator will be having the magnets. stator will be having the magnets to produce your magnetic field. Okay, so these are now called as poles. These are now called as poles. They'll be calling this segment as a poles. Okay, so and this is under your armature. This entire part is your armature. Okay, so this armature will be having your current carrying conductor. So when this rotates, it cuts the magnetic field. It cuts the magnetic field. This is north, and if this is south, means it moves from north to south, right? So the armature will be cutting your magnetic field to produce your current. Okay, so here you can see with the construction yoke. So yoke is nothing but the outermost part, like for protection. Okay, outer part for protection. So generally, how it is also called as frame. So it provides a mechanical support for the poles. So the material used will be of low reluctance. So why low reluctance means then only the magnetic field developed will be very high. So for that purpose, we will be making use of low reluctance material. So some of the low reluctance material are cast iron, silicon steel, rolled steel, and cast steel. Okay. So next, poles and pole core. So as I said, there will be the poles, right? So this contributes to your poles. So this is what your poles look like. Okay, this is your poles. So the poles are nothing but electromagnet. So you have to see with the usage for what the function of your poles. It mainly produces the magnetic flux when the field winding is excited. So generally here you can see there will be two types of winding. Okay, so as I said, we will be making use of magnets, right? So magnets can be either electromagnet, can be either electromagnet or permanent magnet. Okay, mostly we'll be making use of the electromagnets. So how we can make steel as a electromagnet means by you can take steel, okay, and you can just wind it with a coil. Okay, after that you can pass electricity through this. Okay, you can pass electricity through this thing, and you can make this as the electromagnet. Okay, and here this winding is called as field winding. So here the field winding is it produces a magnetic flux when the field winding is excited. So the field winding will be wound like this over here, will be wound over here, and if you're exciting this thing means this pole means your magnetic field will be start to produce. So the north will be coming out. So this is done using lamination of a particular shape in order to reduce the eddy current loss. So as we have seen with respect to your transformer, the same concept is used. Not to make reduce your uh, eddy current loss, you will be laminating it. So next is about your pole shoe. So pole shoe is nothing but an extended part of your pole. So if this is a pole means this up to this it is a pole. Okay. So after that this part will be contributing to your pole shoe. So it is an extended part of pole. Okay. Due to its typical shape, it enlarges the area of the pole so that more flux can pass. So the usage of pole shoe is that to produce more flux. Okay. So the materials used will be of again it will be of low reluctance material. So next coming to the field winding. Okay, so here it is given clearly. This is your field winding. So the coil wound on the pole core is called as field coils. The field coils is connected in the series. So here this is an important. The field coils will be always connected in series, not in a parallel connection. So in a series only the current flow will be very high. Okay. current is passed parallel through the field winding, okay, in a specific direction to magnetize the poles. Thus, a magnetic flux is produced. So here, how the magnetic flux will be produced means between the air gap and the pole. Okay. So if this is the air gap means, so the magnetic flux will be produced between the air gap and the pole. So this is where it just starts to produce. The field winding is also called as exciting winding. The materials used will be of copper, which means it will be having very high conductivity. Due to the current flowing through the field winding, alternate north and south poles will be produced. So armature core, this is the image of your armature core. Okay, so here you can see the windings. So the windings, armature core is nothing but a cylindrical drum mounted on the shaft. Okay, uh, so it is provided with large number of slots all over its periphery. Armature connectors will be placed in these slots. So the material used, again, this will need to provide a low reluctance path. Okay, so material used will be of low reluctance and it must have a very high permeability. Coming to the armature winding, so we have seen about the armature core. Okay, so this is what your armature core will be look like, and this will be your core part, and this is your windings. So the armature conductor will be interconnected to form your armature winding. When the armature winding is rotated using a prime mover, as I said in the principle of operation, it cuts your magnetic flux lines and the voltage will be produced. Okay, so armature windings is connected to the external armature winding is connected to the external circuit or the load through a commutator or brushes. So this is what the important thing. So the armature winding is the output area. So from that output area, it is connected. The output will be taken out through your commutator and brushes. So here the materials used is will be of copper again, because the conductivity of copper is very high. So we'll be always making use of copper for any kind of winding. Okay. Coming to the commutator, this is a very important thing. So you have to know. So it is nothing but a cylindrical drum. So here you can see it is nothing but a cylindrical drum mounted on the shaft with the armature core. It is made up of large number of wedge-shaped segments. So here you can see there will be some type of grooves over it. The segments are insulated from each other by thin layer of mica. Okay, so mainly it will be like a what you can say it as a safety purpose. Also, they'll be make use of mica as an insulation. Armature windings are tapped at various points, and these tappings are successfully connected to various segments. So the function of this commutator is to convert your AC generated EMF, okay, into DC. So the whenever the magnetic flux of lines are cut by the conductors, okay, whenever it is cut by the conductors, the EMF generator will be of alternating in nature. Okay, the EMF generator will be of alternating in nature. So in order to have a, we are now seeing about DC motor, right? So in order to have a unidirectional EMF or DC, you will be making use of this commutator. So this will be made up of insulating material like mica. The next one is your brushes. So the function of the brushes is to collect the current. Okay, that is the output. Okay, output current. So this is your brushes. Collect the output current from your commutator and apply it to the external load. Okay. So the material used will be of carbon, and this will be in rectangular shape. So here you can see it very clearly. Okay. So this is what with respect to your construction of your DC motor. Okay.